Hello everybody, I'm Marco Mercuri.
And I'm Ping Jacksaw. We are both PhD students at the Catholic University of Leuven in Belgium.
In this video we'll show you how to use radar techniques to develop a long-term health monitoring system in a home environment, and in particular aiming at real-time contactless fall detection and tagless localization, meaning without any use of RFID card on the person.
The easiest way to determine speed using a radar system is to transmit a single frequency and to exploit the Doppler effect. Imagine transmitting a single tone or continuous wave to a target situated at a distance r away from the radar's antennas. The reflected signal is collected by the receiver. Compared to the transmitted signal, the reflected signal will be shifted in phase by a factor phi depending on the target's distance r. Mixing a copy of the transmitted signal with the received signal, the radar will produce a baseband signal that is proportional to cos phi. For a moving target, the distance r varies in time, which means that the phase phi will vary proportionally to the target speed. That is, the frequency of the baseband signal will then change proportionally with the target speed, as you can see here. However, a single tone is not able to detect absolute distances. To do so, a step frequency continuous wave signal should be transmitted to the target. It consists of n continuous wave pulses, whose frequencies are increased from pulse to pulse by a fixed increment delta f.
The presented system consists of a sensor combining radar, computational and wireless communication capabilities, and a base station for data processing. A radar waveform, T, is continuously generated and transmitted to the target. The reflected echo, R, containing the target speed and absolute distance information, is collected by the receiver. After an analog to digital conversion, ADC, the resulting I and Q baseband signals are transmitted wirelessly to the base station. The latter, consisting of a Zigbee module, a laptop, and a microcontroller, is used to remotely determine the target's absolute distance and to distinguish a fall event from normal movements.
The radar waveform consists of a 5.8 GHz tone used to determine the target speed, alternated with the step frequency continuous wave SFCW waveform used to determine the target's absolute distance. A movement classification based on a machine learning technique is used to assess the changes in speed experienced during a fall or a normal movement. In fact, during the fall, the frequency of the baseband speed signal increases continuously over time, while in the case of normal movements, the frequency is either quite constant over time or experiences gradual changes. On the other hand, the target's range profile is determined by applying the inverse fast Fourier transform, IFFT, to the SFCW samples. The figure below shows the range profile of a person located 4 meters away from the antennas.
Now we are going to show you an example of real-time fall event detection in a real situation. The experimental validation has been conducted using a human subject in a lab arranged to mimic a real 5x5 square meters living room. As you can see, the room contains furniture, a metal shelf, a sofa, tables, computers and chairs, located around and in the center of the room. The volunteer was allowed to move without restrictions in the whole room, meaning that he could mimic all the typical movements that are normally achieved in a domestic environment, such as working at the PC, watching a film, resting on the sofa, walking, using the cellular, moving chairs, open the window, and so on. Let's see now what happens in case of fall incident. An alarm will be activated whether a fall is detected. As you can see, the system was able to detect the fall in real time.
In this video, a health monitoring system based on a microwave radar has been demonstrated for long-term health monitoring in a home environment. As shown, it is able to determine the target's absolute distance and to detect emergency situations, namely fall incidents in real time without reporting false alarms. Thank you very much for watching. We really hope that you have enjoyed this video.
Until next time, bye!